Hello students, this is Ms. Goel from my team Wisdom. Today we will be learning the second chapter of chemistry, that is acid, bases and salt. Let's start. Yeah. So what do we mean by the acid, bases and salt? Firstly, we'll discuss these things. Firstly, acids. What do we mean by acid? Substances which are sour in taste. Those are known as acids, but not all the sour substances are acids, of course. One another thing, they give H positive ions in the solution. For example, here you can see this is HCl. It is giving you H positive and Cl negative. Because it is giving this H positive ion in the solution, so it is called as an acid, right? Another example, we can say sulfuric acid. It is giving H positive ions and sulfate ions. So those substances which give H positive ions in the solution and are sour in taste, they are known as acids, fine? And we have some other acids also. For example, lemon juice, citric acid is there. In vinegar, acetic acid is there. In orange juice, again citric acid is there. So we have certain substances from our daily life and certain in chemistry lab where we can find acids. Next, bases. What do we mean by bases? Those substances which are bitter in taste, they are known as bases. And they give hydroxide ions in the solution, these OH negative ions in the solution. Some common bases are soap, baking soda. Chemical bases are sodium hydroxide, potassium hydroxide. Here you can see the reactions also. This is NaOH, it is giving you Na positive ion, OH negative ion. Because the sodium hydroxide is giving this hydroxide ion, so it is called as a base. Another example, we can see this magnesium hydroxide. It is giving you magnesium ion and hydroxide ions. Because this is giving this hydroxide ion, so it is also called as a base. And one more thing, these bases and these acids, they are giving these ions only in the presence of water. When you dissolve these substances in water, only then they are giving these ions, right? So acids are something which are sour in taste and give H positive ions in solution. Bases which are bitter in taste and give hydroxide ions in solution. So these are acids and bases. Now what happens when an acid and a base combines? Whenever an acid and a base combine, they give a neutral substance which is called as salt. You can also say that acid plus base gives you salt. Acid plus base combines to give a salt. And this reaction is known as a neutralization reaction. Okay? So whenever an acid and base combines, they form salt, and this particular reaction is known as a neutralization reaction. Basically, they neutralize the effect of each other. Now we have a question that let's suppose you have a person. Let's read the question first. What will be given to a person having acidity after overeating? That means there is a person who has done some overeating and then he is having some acidity problem. This problem we have seen in our daily lives also. So what should be given to that person? Our options are lemon juice, vinegar or baking soda solution. How can we decide that what shall be given to that person? Right? Firstly, the person is having acidity, means excess acid is there. So we shall give a substance which will neutralize the effect of acid, right? Not a substance which will enhance the effect of acid. And neutralization of an acid can only be done with the help of a base. We have already studied here that acid plus base gives salt, and this is neutralization reaction. Means base will nullify the effect of acid and acid will neutralize the effect of base. So here, the person who's having acidity must be given a base, right? And out of these three, only baking soda is a base. So baking soda solution should be provided to that person. And in this case, this baking soda is known as antacid. So now we have learned this new term antacid. What that means? That a substance which is given to neutralize the effect of acid, that is known as antacid, right? Okay, so this we have studied till now, that what do we mean by acid, what do we mean by base, When they combine, they are giving a salt, which is a neutralization reaction, right? Now, okay, before moving to the next slide, can you tell me there are some antacids from our daily life? Right? We have, many of you must have taken that also. Okay, now the next thing is indicator. From a layman point of view, what do we mean by indicator? Indicator is any substance that is indicating something or that is telling something, right? In case of acid and bases, we can say indicator is a substance which tells us whether a given substance is an acid or a base. And how it does so? It does so by change in its color, right? So indicator is a dye that changes color when put in acid or base. That means indicator is having certain color. And when you put in acid, it shows different color. When you put in base, it shows some different color. And by seeing those changes in the color, we can say that yes, this is acid and yes, this is a base. Okay. We have two types of indicator: natural indicator, synthetic indicator. Natural indicator is litmus. From that, we make these two paper, litmus paper. It is blue litmus paper. This is red litmus paper. Synthetic indicator, phenolphthalein, methyl orange. This is phenolphthalein. It is neutral and colorless in color, I can say. Methyl orange, this is orange in color. Now let's see how they changes their color. Now, firstly, we talk about litmus solution or paper. If we talk about litmus solution, it is purple in color. But litmus paper, as we have seen in this slide also, that they are two in color, blue and red. Now, when you put this litmus paper in acid, right? This was blue litmus paper. You can see this person is holding the blue litmus paper. But when we put in acid, it turns into red color. That means acid will turn blue litmus into red. And here this person is holding this red litmus paper. And when we put it in base, it turns into blue. That means base will turn red litmus to blue. This you can also learn by the way that base is B. It starts from B. And the color blue starts from B. So base is blue, acid is red. Fine? Okay. Then the next indicator is phenolphthalein. It is actually colorless in color. But when you put in acid solution, this was acid. When you put some phenolphthalein into it, it remains colorless. But if you put phenolphthalein into a base, it turns pink in color. Okay. Here we can see. Here you can see that it is written alkali, not a base. So water-soluble bases are known as alkali. Point to note that water-soluble bases are known as alkali. Now, this is methyl orange. This is methyl orange. It is orange in color. When you put this methyl orange into acid, it turns red in color. If you put it in base, it turns yellow in color. Acid solution is red. Base solution turns it yellow. Next is turmeric. Turmeric we all use in our daily life. It is yellow in color. We all know that. If on turmeric we put acid solution, it remains yellow. But if you put base, it turns into red. Now you have to learn these color changes. Okay. Now let's do a simple activity. In this activity, you have certain these samples and you have to tell that what will be the color in these particular solutions. Firstly, this HCl, it is an acid or a base? Acid. So I have written A over here. Similarly, this H2SO4, HNO3, CH3COH. All these three are acids. So I have written A in front of them. This NaOH, calcium hydroxide, KOH, MgOH twice, NH4OH, all these are bases. So I have written B over here, right? Now, this HCl is an acid. So red litmus will remain red. Blue litmus will change into red color. So I have written red. Phenolphthalein remains colorless in acidic solution. So it's colorless. Methyl orange turns red in acidic solution. So here is red. Now for these three, you can write it down. Similarly, I have written for bases. NaOH is a base. So red litmus changes into blue. Blue litmus remains blue in color. Phenolphthalein changes into pink. And this methyl orange changes into yellow. Okay. Now for these, you can do by yourself. Now we'll study the last type of indicator, that is the olfactory indicator. Olfactory, you all can sense or you all can judge. It is something related to the smell, right? So olfactory indicators are those indicators which tells about a given substance as an acid or a base by change in the smell. Fine. Substances whose odor changes in acidic or basic medium are called as olfactory indicators. For example, onion, vanilla essence, clove oil. We all know these three have their particular smell, right? Now, if you put acid solution into these substances, then the smell will not vanish. It will remain as such. But if you put a base onto them, then the smell vanishes out. Smell cannot be detected any further. So that means these olfactory indicators or these substances retain their smell in acidic solution, but their smell cannot be detected in base solution. Right? This way we can differentiate between an acid and a base. For this, you can do one simple activity at your homes also. I'll suggest please try that. For that, take a finely chopped onion, put it into a plastic bag, take 2 cloth strips, put it into that bag, seal it airtight and keep it in fridge overnight. Next day, just take out the two cloth strips. They must be having the particular smell of onion on one cloth strip. Put some vinegar or acetic acid. Of course, vinegar is having acetic acid. And on the other, put some baking soda solution. That baking soda is a base, right? So you will find out the cloth strip on which vinegar was put, it is still having the smell, but the one having baking soda onto it, the smell vanishes. So base smell gone, acid smell is still there, right? So this way we can say that this is an acid or this is a base. In this video, I'll discuss till here only. If you want to have the further discussion or further detailed things, then you can join our regular classes. Thanks for watching the video. If you have any doubt or you want to ask something, then you can write in the comment section below. Keep watching and please don't forget to subscribe our channel. Thank you. Keep learning.